Hello everybody, good evening all of you. I welcome you to Chandra classes. As you know that in this entire series of lectures, the subject matter of our discussion is geography. And in today's lecture, my friends, we are going to discuss about heliocentric model of the discovery of universe. As you know that in our last lecture, we discussed in detail the geocentric model of the discovery of universe, and in this lecture today we are going to discuss the heliocentric model of the discovery of universe. And in this model, while discussing, we are not just going to be concentrated over exactly the model. We'll be just expanding and finding out the things of our relevance, meaning the relevance of our exams. So that's why we'll be looking into this model with respect to our exam, that what we could draw along with understanding the model, what kind of things we can draw out from that model which could be relevant for our upcoming exams for the purpose of general studies. So that's why we are just going to discuss it now, the heliocentric model of the discovery of universe. The heliocentric model, because in our earlier lecture, in our earlier lecture, we discussed about the geocentric model in detail, comprehensive detail. And in today's lecture, we will be just discussing about the heliocentric model. We have discussed the geocentric one. We will be discussing about heliocentric. Heliocentric. We have already discussed, told you, the geocentric our last lecture. Geocentric model, what does it mean? Is the proponents or the supporters of geocentric model, they were saying, they were trying to prove through various kind of means, arguments, that the earth, geo means earth, that earth is at the center of the universe. They try to prove, as we have seen in our last lecture, the philosophers and astronomers like Aristotle, we have seen Aristotle, and then after Ptolemy, Aristotle and Ptolemy, they formalized the geocentric model through various arguments. We have discussed all of them in detail in our last lecture. Today we are going to look into the heliocentric, and we'll try to draw the subject matter of our own relevance, the relevance of the exam, which could be relevant for our exams, upcoming exams. So in heliocentric model, as the name suggests, because wherever helio is a kind of, for example, if before any word, the helio prefix is added, it means that word is something related to the sun, something related to the existence of the sun, or any quality or characteristic of the sun. So the heliocentric, I mean the next, if you just next part of this word centric, centric meaning center, helio talk about the sun. So sun is at the center, just suggests, the name itself suggests that sun is at the center model. So in this model, we'll be looking various proposers, various supporters of the model. They'll try to prove that sun is at the center of the universe. Because as we have discussed, that earlier our understanding of the universe was extremely limited. We were not very much aware about the outer universe, outer galaxies, various different clusters of galaxies. We were not aware of about them. Even we were not aware of the local group, which is our group of galaxies, meaning our Milky Way galaxy is the part of the local group, which is around, which is containing around 30 galaxies. So we were even not aware of that part as well. We were maximum aware about our own galaxy, Milky Way. So in heliocentric model, uh, They were just talking about that the sun is at the center of the universe. And the first important figure supporter of heliocentric model was Copernicus. Copernicus was the first person who just supported and extended this model. As we'll be looking at, just Copernicus. 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 Full name was Nicholas Copernicus. का पूरा नाम था निकोल. So Copernicus, 16th century, 16 in 16th century. So he belonged to especially to 16th century, and he talked about heliocentric model around 16th century. So Copernicus said that the universe is sun-centered. The universe is sun-centered. 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 As we have discussed, heliocentric, sun-centered. Sun is at the center of the universe. He talked about this model. Sun is at the center of the universe. And he said, the next important point, he said, and all the other objects in the universe, meaning all the other planets, stars, whatever they are, all the other objects in the universe, they revolve around the sun. They were saying that all the objects, planets revolve around the earth. But here Copernicus said that all the objects and all the kind of celestial objects, celestial bodies, they revolve, they revolve, they revolve around the sun and not the earth. This is the most important fact. They revolve, they revolve around the sun, the sun. And the orbit of revolution is circular, circular. Still, Copernicus could not find out exact reality because he still suggested that the orbit of revolution is still circular. As we know now, भी मुझे पता है, हम लोगों को पता है कि जो ऑर्बिट है रिवॉल्यूशन की अराउंड द सन ऑल द प्लैनेट्स, इट इज नॉट एग्जैक्टली सर्कुलर, इज इलिप्टिकल ऑर्बिट है. आगे हम देखेंगे अभी डिस्कस. So he said that the sun is at the center of the universe and all the objects in the universe, celestial objects, they revolve around the sun and they revolve in the circular orbit. So this was the finding, the observation of Copernicus, 16th. But almost nobody tries to believe it because the geocentric model was so much understood, so much kind of in-depth available that most of the people in society, they were just exactly not believing this concept of Copernicus. Most of the uh, kind of persons, they were just not believing because this was just coming after centuries. Because as we have discussed, geocentric model, it was just going into the society, through the society since long ago. इस सेकेंड सेंचुरी से ही ये मॉडल पॉपुलर हो गया था टॉलमी के द्वारा. तो ये मॉडल तो इन डेप्थ हमारे जो है हमारे अंदर बैठ चुका था, रिलीजियस टेक्स्ट तक में शामिल हो चुका था जियोसेंट्रिक मॉडल. तो इतनी जल्दी ये हेलियोसेंट्रिक मॉडल के बारे में कोई मानने वाला नहीं था. ओके, so Copernicus talked about it, but and he talked all those things in his book named On the Revolution. On the Revolution. On the Revolution. Revolution. On the Revolution. On the Revolution. लोग इस मॉडल के बारे में बिलीव इस हद तक नहीं कर रहे थे कि ऑन द रिवॉल्यूशंस जो बुक थी इनकी, इट वाज जस्ट पुट इनटू द फॉरबिडन कैटेगरी. So just you can see here the belief system and the acceptance of the geocentric model was so strong that people were unable to believe the heliocentric model as proposed by Copernicus in the formal setting first of all. Then after the Copernicus, there came Galileo, second most important person here. After Copernicus, Galileo tried to just extend this model. Galileo tried to just extend this Galileo. And Galileo in 17th century, next century, tried to extend the heliocentric model as it was proposed by Copernicus. And he said, so through his and how he observed the things, because if you want to support any model, if you want to extend any model, you need to have some research. So he was having a telescope, strong telescope. So through his telescopic observations, he tried to find out the various details. And what type of details he could find out through his telescopic observations, we will see here. In his telescopic observations, he searched 4 moons of the Jupiter. इन्होंने 4 मून, जुपिटर के 4 मून्स इन्होंने डिस्कवर किए टेलीस्कोपिक अपने ऑब्जर्वेशन, और उनको गैलीलियो के मून्स के नाम से जाना भी जाता है. तो 4 मून्स ऑफ द जुपिटर, 4 मून्स ऑफ जुपिटर, 4 moons of Jupiter. They are very popular moons, and many times many questions are being framed in various competitive exams from that. 4 moons of Jupiter. What are those moons? Of course, we'll see that. So it is very important. The moons were Ganymede, 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 Europa, Ganymede, Europa, Europa, Callisto, Callisto, and Io. Io. So these were 4 moons of Jupiter discovered by Galileo through telescopic observation. उन्होंने अपने बड़े बड़े टेलीस्कोप लगाए, देखा, और उन्होंने ये 4 moons डिस्कवर. जब उन्होंने ये 4 moons डिस्कवर किए, and since these are the moons of Jupiter, so they were revolving around the Jupiter. So he said that everything, as earlier we were saying in the geocentric model, that every object, everything in the universe is revolving around the Earth, that this is not true, because here there are 4 moons of the Jupiter, they are revolving around the Jupiter and not the Earth. So it extended the heliocentric model कि सभी चीजें अर्थ के अराउंड नहीं घूम रही हैं, कुछ चीजें ऐसी भी हैं जो उससे हटके भी हैं, they are different. So it extended the heliocentric model as earlier suggested by Copernicus. And he also found out the phases, different phases of Venus, phases of Venus. इन्होंने वीनस के बहुत सारे फेज भी ऑब्जर्व किए, phases of Venus. It also extended, it also emboldened the heliocentric. जो सारे ऑब्जेक्ट्स हैं ये यूनिवर्स में, सारे ऑब्जेक्ट जो अभी तक हमें पता है, ये दे आर नॉट जस्ट रिवॉल्विंग अराउंड द अर्थ, दे आर वेरी डिफरेंट. So it extended some type. It was not just a crystal clear picture of heliocentric model, but it made heliocentric model more stronger as compared to the Copernicus, as suggested by the Copernicus. So these observations Galileo did in 17th century using his telescope, powerful telescope. And then after Galileo, After Galileo, there came Kepler, one of the most important figures here. There came Kepler. Kepler also belonged to around 17th century. Around 17th century. So Kepler, the first important thing he did, he introduced the elliptical orbit. He introduced the elliptical orbit. Elliptical orbit. Elliptical orbit. Because we know that till then, even Copernicus tried to find out something beyond, but still he was stuck to the circular orbit. First time, most importantly, Kepler tried to find out the elliptical orbits. He also used his telescopes, very strong telescopes. उसका यूज करते हुए इन्होंने पाया कि जो भी ऑब्जेक्ट्स जो हमारे सन के अराउंड रिवॉल्व कर भी रहे हैं वो सर्कुलर ऑर्बिट में नहीं है, इलिप्टिकल ऑर्बिट में. इलिप्टिकल ऑर्बिट क्या होती है अभी हम जानेंगे. इलिप्टिकल ऑर्बिट एंड he gave three laws of planetary motion. Three laws of planetary motion. Three laws of planetary motion. उन्होंने प्लैनेटरी मोशंस के कि प्लैनेट्स जो है वो कैसे रिवॉल्व करते हैं उसके उन्होंने पूरे लॉज ही बता दिए. थ्री लॉज ऑफ प्लैनेटरी, ताकि पूरी पिक्चर जो है. तो ही प्रेजेंटेड थ्री लॉज ऑफ प्लैनेट. तीन उन्होंने लॉज बता दिए एंड दोज लॉज आर वेरी इंपॉर्टेंट फॉर आवर एग्जाम. इसीलिए हम उनको समझें क्या लॉज उन्होंने बताए और उसकी मीनिंग क्या है. तो in his three laws of planetary motions, Kepler just took the heliocentric model to the next level. Here are the laws of planetary motion given by Kepler. Kepler ने बताया जो laws दिए. The first law he told, the planets move in the elliptical orbits with the sun at one of the foci. He said कि जो planets हमारी जो सन के अराउंड एक इलिप्टिकल ऑर्बिट में घूम रहे हैं, इलिप्टिकल ऑर्बिट में घूम रहे हैं, उस इलिप्टिकल ऑर्बिट के वन फोकस पर सन जो है सिचुएटेड है और जो बाकी इलिप्टिकल ऑर्बिट है उस पे जो है अर्थ या बाकी सारे प्लैनेट्स वो सन को रिवॉल्व कर रहे हैं. इसको हम आप समझते हैं. बिकॉज वी नो दैट जियोग्राफी इज वेरी पिक्टोग्राफिक. सो पिक्चर बिना बिना without making pictures, without making diagrams, it could be difficult to understand. So we are going to make. He said in his first law, the first law says, the planets move in the elliptical orbits with the sun at one of the foci. What does it mean? It means, try to understand it, it is very important. It means, he said, first of all, we should just understand what is elliptical orbit. We have discussed the circular orbit, everybody knows. For example, this is a circular orbit. Circular orbit. And this is the focus, meaning the center point. Circular orbit means circle, and this is the center of the circle. So in circular orbit, the sun stays here, meaning the object around which the things are revolving, that stays here. वो यहाँ पर होता है और बाकी planets वो सारे इधर इधर revolve कर रहे होते हैं. But he suggested, but the Kepler suggested that the orbit is not circular, it is elliptical. तो अब हमें देखना होगा elliptical orbit क्या है. इलिप्टिकल ऑर्बिट को हम ऐसे समझते हैं कि ये एक सर्किल हमने बनाया और एक दूसरा सर्किल हम ऐसा बनाते हैं. द सेकेंड सर्किल वी मेक which is going through the focus of the first circle, like that, and this is the focus of this circle. This is the focus of this circle, meaning center. This is the center of center, or we also call it focus. So this is the focus of this circle, this is the focus of this circle, Now see, if we just attach a line from here, here as well, like that, and we erase the lines in, this is the easiest way to understand the elliptical, or easiest way to understand the elliptical. Now you'll never forget how the elliptical, like how it works, and we will also try to explain further the law as given by Kepler. So now this comes our elliptical orbit. This comes our elliptical orbit. Now you see that this elliptical orbit, I mean, there are two focus points, and two focus points. In plural, we call it foci. We call the focus points foci or foci. Yes. So this is the elliptical orbit. This is the elliptical orbit, and the law, first law says planets move in elliptical orbits with the sun at one of the foci. One of the foci. One of the foci. मीनिंग ये कह रहे हैं कि जो प्लैनेट्स हैं, जितने भी जो सन के अराउंड रिवॉल्व कर रहे हैं, फॉर एग्जांपल दीज आर प्लैनेट्स, दे आर रिवॉल्विंग अराउंड द सन, दीज आर रिवॉल्विंग अराउंड द सन। वो इस पहली चीज तो इलिप्टिकल ऑर्बिट में रिवॉल्व कर रहे हैं, और इस इलिप्टिकल ऑर्बिट में व्हाट इज द लोकेशन ऑफ द सन, वो कह रहे हैं कि वन ऑफ द फोसाई, ये टू फोकस हैं तो प्लूरल में हम फोसाई कहते हैं। सो वन ऑफ द फोसाई, यानी जो टू फोकस हैं उनमें एक फोकस पर सन होता है। सपोज कर लो कि यहाँ पर हमारे इस फोकस पर सन है, दिस इज द सन, दिस इज द सन हियर, दिस इज द सन। So sun is at one of the foci of the elliptical orbit, and planets are revolving around the sun. So he tried to say this thing in his first law of planetary motion. Very easy to understand in the pictographic form. The planets are revolving around the sun. Planets are revolving around the sun. Sun in the elliptical orbit. When just if we take a rubber band and we stretch is a little, it just turn out to be in elliptical orbit. So this is the elliptical orbit. So he said the planets are revolving around the sun and in the elliptical orbit, and sun is situated in one of its foci. जो इलिप्टिकल ऑर्बिट के हमारे दो फोकस पॉइंट हैं, उनके एक फोकस पॉइंट पर सन हमारा होता है। तो ये उन्होंने पहले अपने ऑब्जर्वेशन में, पहले लॉ में बताया, लॉज ऑफ प्लैनेटरी मोशन। द सेकेंड लॉ सेज अ लाइन ज्वाइनिंग अ प्लैनेट टू द सन sweeps equal areas in equal times. Now just see, line joining the planet to the sun, line joining the planet to the sun, line joining to the planet, line joining the planet to the sun. For example, this is a planet, this is a, now we just yeah, of course. For example, this is a planet, this is a planet which is revolving around the sun, orbiting around the sun in the elliptical orbit. And if we just consider an imaginary line, if we just consider, so if we just consider an imaginary line joining the sun to the planet, and suppose that in 1 hour or in one day, for example, in one day, the displacement the of this planet, just it reaches from here to here. The planet reaches to this location, new location. because it is revolving around the sun. So after some time, let's say one day, it reaches from here to here. So the now the new line joining the sun to the planet will be like that. Will be like. Now, if we consider this area, this entire area, this entire area, this entire area, imaginary area, the slice of, it looks like slice of pizza. So this entire area, this entire area. So for example, the planet, this planet, let's say Earth, it moved from here to this location from point A to point B in one day and covered this entire area. This entire area. And this entire area is, let's say, 100 square kilometer. For example, let's say that this area is 100 square kilometer and the Earth covered this area in one day, meaning 24 hours. So when the Earth, for example, after revolving entire distance, for example, Earth reaches here. For example, Earth reaches here. Earth reaches here, this place, this place. Now, if we just calculate, for example, this is point C, and after one day, because in one day, the Earth covered here this area of 100 square kilometers. The displacement was, the distance it covered, it was very low. It was very low. But here, in one day, it will again cover the equal amount of area. For example, 100 square kilometer, equal area in one day. So here, since we know that the distance between the Earth and the Sun, distance between the Earth and the Sun is less as compared to the distance here, because this was the Earth traveling farthest to the Sun here. यहाँ सबसे दूरी पर थी, यहाँ नजदीक है. फिर अगेन वो वन डे में, यानी वन डे में वो यहाँ से यहाँ डिस्प्लेस हुई थी. इधर वो वन डे में, एक ही दिन में वो यहाँ से लेट्स से यहाँ पहुंच गई. डिस्प्लेस्ड फ्रॉम दिस प्लेस सी टू प्लेस डी, प्लेस डी पर पहुंच गई. traveled from place C to place D. And if we again join a line between the Earth to the Sun, so this area, if Earth took exactly one day in traveling this distance, so this area that the Earth covered, this slice, the area of this slice must be equal to the area of this slice, because the time is same. In one day, if the Earth covers the area here, for example, area 100 square kilometers, so in one day, again the Earth will cover the same area of 100 square kilometers here as well. 100 square kilometers here as well. These are tough concepts, but I am making them very easier for you to understand. क्योंकि अगर हम पिक्टोग्राफिक फॉर्म में से समझते हैं, so they are going to stay in our minds forever. We are just not easily going to forget them. They are not going to disappear. तो इनका कहना था कि जो भी प्लैनेट, वो चाहे वो अगर आप इसके इसेंस को समझो, जब प्लैनेट अर्थ से, सन से दूर होता है, जितना अधिक दूरी पर वो सन को रिवॉल्व कर रहा होता है, तब उसकी स्पीड धीमी होती है. और जब वो सन के पास होता है, क्लोज होता है, तब रिवॉल्व कर रहा होता है, तब उसकी स्पीड तेज हो जाती है. दिस इज द एसेंस ऑफ द थियरी, द सेकंड लॉ. एंड दैट्स व्हाई when the Earth is closer to the Sun, manages to cover that amount of area, in the exact same time, one day. Because here the speed increases. If the speed would not have been increasing, the Earth would not be covering the same area as it was covering here, because then the Earth could have displaced or traveled just this only distance. Maybe this distance was, for example, 1000 kilometers from here to here. For example, 1000 kilometers. 1000 kilometers. Again, the Earth would have traveled, if the speed was same, again the Earth would have traveled the distance of 1000 kilometer and reached to the here, then the area, this area would have been much lesser as compared to this area. But since the speed of the earth, meaning any planet revolving around the sun, it increases h it reaches to the, I mean closer to the sun, जैसे जैसे नजदीक सन के नजदीक आता जाता है इसकी स्पीड बढ़ती जाती है। इस अपने इलिप्टिकल ऑर्बिट में जैसे जैसे वो सन के नजदीक आता जाता है, फॉर एग्जांपल दिस इज द फारदेस्ट पॉइंट and now it is coming closer to the sun, and when it reaches here it becomes closest to the sun, and here it is farthest to the sun. We'll be discussing about it, aphelion, perihelion, all those concepts in our later lecture. So this was the essence of the second law of motion suggested by Kepler, that as much as the planet reaches closer to the sun, its speed of revolution increases. And that's why it could cover the same area as it was covering while it was traveling farthest to the sun. It covers the same area while being closest to the sun, because of the increase in speed. Okay, now we just see the third one. The square of a planet's orbital period is proportional to the cube of its coverage distance from the sun. If we just simply try to understand, if we simply try to understand, it says that any planet, for example, we know that there are number of planets in the sun. For example, this is the sun, this is the sun, and there are many planets, Mercury, Venus, Earth, etc. So it says if the distance is increasing, meaning if any planet, अगर उसकी डिस्टेंस सन से बढ़ रही है, अगर उसकी सन से डिस्टेंस बढ़ रही है, तो उसको जो टाइम लगेगा सन को ऑर्बिट करने में वो ज्यादा होगा, वो ज्यादा टाइम लगेगा, इज सेइंग अंडर हिज थर्ड लॉ ऑफ मोशन। एंड वी नो इट एज वेल कि हमारा क्लोजेस्ट कौन सा प्लैनेट है सन के, वो है मरकरी, मरकरी, वीनस, अर्थ, वी नो ऑल दीज प्लैनेट्स। तो मरकरी, we know that it takes only 88 days, around 88 earth days, 88 earth days to complete one revolution, one orbit around the sun. Venus takes, as per the third law of the Kepler, as the third law as presented by Kepler, the third law of motion, Venus would be taking, definitely would be taking more kind of days, longer period as compared to the Mercury. So Venus takes here 2 to 5 days to have one complete orbit around the sun. And about Earth, we of course we know very well. Earth takes 1 year, meaning 365 days. And similarly, if we just talk about Jupiter, humongous, it takes around 12 Earth years. 12 Earth years to complete one orbit. So third law is saying as farthest as the planet is from the sun, it will take longer to complete one revolution around the sun. So the essence of the third law is this. So this way, the now just see, this made entire picture kind of very clear, and now there was tremendous support for the heliocentric model because of these three laws presented by Kepler. Kepler, known as Kepler's laws of planetary motion, and they are very important. You must know them. They are very important. I tried to discuss in detail and in pictographic form for your better understanding, so that you are just not forgetting it. But you need to know them. They could be the part of any question anytime in the upcoming exam. Then after this, then after the Kepler, अब केपलर ने तो हीलियोसेंट्रिक मॉडल को एक नेक्स्ट लेवल पे पहुंचा दिया, उन्होंने जो 3 लॉज ऑफ प्लैनेट दे दिया। नाउ द हीलियोसेंट्रिक मॉडल वाज जस्ट ट्रेवलिंग वेरी हाई। अब ये पहले जैसा कॉपरनिकस ने बताया, बट दैट टाइम इट वाज जस्ट सप्रेस्ड, दबा दिया गया, भरने नहीं दिया, बिकॉज ऑफ सो काइंड ऑफ डोमिनेंस ऑफ द जियोसेंट्रिक। बट अब केपलर ने तो इसे पूरी तरह से प्रूव ही कर दिया यूजिंग टेलीस्कोपिक ऑब्जर्वेशन। तो अब ये रिफ्यूट करना बहुत ही कठिन हो गया लोगों के लिए। अब लोग इसमें इंटरेस्टेड होने लग गए, क्या ये मॉडल सही है, क्या सन ही एट द सेंटर ऑफ द यूनिवर्स है एंड ऑल अदर ऑब्जेक्ट्स आर रिवॉल्विंग अराउंड द सन। तो अब क्या हुआ कि लोगों में एक्सेप्टेंस धीरे धीरे बढ़ने लग गई, बिकॉज नाउ दे वर हैविंग प्रैक्टिकल काइंड ऑफ ऑब्जर्वेशंस observed through telescopes and various other means calculations. So after Kepler, there came Newton. Newton also did a few important things to extend the heliocentric model. Newton did a lot of things with respect to the physics and science, but here we are talking that Newton did something which extended the acceptance of the heliocentric. हेलियोसेंट्रिक मॉडल की एक्सेप्टेंस को और अधिक बढ़ा दिया सोसाइटी में, लोग उसको अब एक्सेप्ट करने लग गए धीरे धीरे। तो द नेक्स्ट फिगर, इंपॉर्टेंट फिगर who extended the heliocentric model, Newton, was Newton. Newton belonged to 17th, 18th century. England belonged to England. He was the scholar of Cambridge University. And he said, because everybody was talking about the revolution, the revolution of the planets around the sun, or the revolution of the planets around the earth, or the celestial objects. But Newton just came out very strong. He said, why this revolution is taking place? He said, this is because of gravitation. He added one other dimension and said, he said, try to just express the planetary motions via universal gravitation. यूनिवर्सल, उन्होंने एक कॉन्सेप्ट ला दिया यूनिवर्सल ग्रेविटेशन का, कि ऐसा कोई भी ऑब्जेक्ट है नहीं यूनिवर्स में जो ग्रेविटेशन न रखता हो। एंड सिंस वी आर टॉकिंग अबाउट सेलेस्टियल ऑब्जेक्ट, दे आर ह्यूमंगस, दे आर बिग, so they have tremendous gravitation. As we know about sun, all the planets are revolving around it very, and under the gravitation, under the gravity. So he propounded the concept of universal gravitation. यूनिवर्सल ग्रेविटेशन को उन्होंने बताया और कहा कि जो भी ये रिवॉल्व कर रहे हैं, ऑर्बिट कर रहे हैं, डिफरेंट प्लैनेट्स एंड डिफरेंट सेलेस्टियल ऑब्जेक्ट्स, एज पीपल वर टॉकिंग अराउंड द सन, इन्होंने कहा सन के अराउंड क्यों रिवॉल्व कर रहे हैं, क्योंकि सन जो है वो एक सबसे बड़ा हमारा सोलर सिस्टम का ऑब्जेक्ट है। सन हमारा यूनिवर्स का सबसे बड़ा ऑब्जेक्ट हो सकता है, तो उसके अराउंड ये रिवॉल्व कर रहे हैं बिकॉज ऑफ द ग्रेविटेशनल पुल। तो इन्होंने ये कॉन्सेप्ट दे दिया, तो इससे और ज़्यादा क्लैरिटी आ गई इन द काइंड ऑफ हेलियोसेंट्रिक मॉडल। बिकॉज अब ऐसा तो कहा नहीं जा सकता था कि अर्थ के अराउंड सारे मूव करेंगे, अर्थ के अराउंड सारे रिवॉल्व करेंगे, क्योंकि अर्थ तो सन से छोटा है, तो उसके ग्रेविटेशन कम होगा, तो उसके अराउंड कैसे ये सारे प्लैनेट्स या सेलेस्टियल ऑब्जेक्ट्स वो रिवॉल्व कर सकते हैं। तो ही गेव अनदर डायमेंशन, universal gravitation. And as we know, it is important to mention here that he wrote a very important book, very popular, would be asked in exams. That was Principia Mathematica. Principia Mathematica, as name suggests, was the book over mathematical calculations. So this was the book of the Newton. In this book, he made various claims and observations with respect to calculations. So this gave a new dimension and support to the heliocentric. Now after the Newton, and this just enhances the acceptance of the heliocentric, because Newton just presented the cause as well. And because till now we were not very much aware about the cause, we were not having any practical understanding of the cause, that why all the planets or the celestial objects, they are revolving around another body. But Newton gave the cause. This is universal gravitation, and this was a kind of very practical cause. It got fitted very quickly. So that's why it gave the heliocentric model a kind of universal acceptance. After the Newton, there comes next important figure, And I think most important figure in the line, that he was E.P. Hubble. E.P. Hubble. E.P. Then Pavel Hubble. E.P. Hubble. Hubble. E.P. Hubble. Early 20th century. 20 most observations made by him. And he belonged to United States. He used a very strong telescope. He used very strong telescope because up to the start of the 20th century, we were having that much strong telescopes. And earlier, the telescopes were primitive types of telescopes. They were not just bringing the clear picture of the universe or in deep. But now in 20th century, we were having that kind of high power telescope. So E.P. Hubble, he used a high power telescope and tried to observe some kind of very important things. Those were those were unknown till then. तो उनके बारे में पता ही नहीं था लोगों को. अभी तक लोग यही जियोसेंट्रिक हेलियोसेंट्रिक पर अटके हुए थे. ईपी हबल एक नया डायमेंशन खोज के ले आए, एंड दैट डायमेंशन became very important to our extended understanding of the universe as we know it now. तो अब हमें पता है कि यूनिवर्स कितना वास्ट है, ह्यूमंगस है. That foundation was put here because before him the people were just fighting over the heliocentric and geocentric model. I mean, not going beyond there because they were just considering या तो अर्थ है सेंटर में या सन है सेंटर में. ईपी हबल brought some new dimension along with completely making the picture clear that earth is not the center of the universe, maybe the sun, but he again extended it to the further dimension. So, and that's why he's also known as father of modern cosmology, because he just put the foundation of modern understanding of the universe. Using his telescopic calculations, he concluded two important things. Concluded two very important things. He said that because till now we were just saying that universe is limited to only our galaxy, meaning the Milky Way. Our own only the Milky Way is the universe. Because we were seeing different stars in the night sky and various other objects in the night sky. So we were seeing them. We were saying that this is the entire universe and this is our galaxy, this is Milky Way, and there is nothing beyond that. इसके अलावा कुछ है ही नहीं. बट हबल ने जब अपने स्ट्रॉन्ग टेलीस्कोप्स को यूज किया तो उन्होंने बहुत अच्छी नई नई फाइंडिंग्स की. द फर्स्ट इंपॉर्टेंट थिंग ही सेड दैट यूनिवर्स इज नॉट लिमिटेड टू आवर ओनली गैलेक्सी. हमारी गैलेक्सी तक ही लिमिटेड नहीं है. मीनिंग यूनिवर्स इज इवन बियॉन्ड आवर गैलेक्सी. ये हमारी गैलेक्सी के बियॉन्ड भी है, यानी ये लिमिटेड नहीं है हमारी गैलेक्सी तक, और भी बहुत सारी गैलेक्सीज हैं इन द यूनिवर्स बियॉन्ड आवर गैलेक्सी. मीनिंग इट हैज द यूनिवर्स कंटेन्स many galaxies. This was his first most important observation, and it was a very new observation because till now we were fighting within the galaxy, and he brought a new extended dimension. Said that universe is not only limited to our galaxy, it is even beyond our galaxy, and universe contains multiple galaxies. बहुत सारी galaxies universe में है. हम तो एक में ही अभी लड़ रहे हैं कि ये इस गैलेक्सी में कौन सेंटर में है. यूनिवर्स तो बहुत, उसमें ऐसी गैलेक्सी बहुत सारी, मिलियंस ऑफ गैलेक्सीज कुड बी देयर. So he brought a very new dimension, and he said that those galaxies, जो गैलेक्सी हैं, they are not stable. They are going far away from us, farther from us. They are going farther from us. और उन्होंने कहा कि जो भी गैलेक्सीज हैं whatever galaxies are in millions, could be any number, they are not stable. वो एक रुकी हुई जगह नहीं है. They are going further from us. वो लगातार हमसे दूर जा रहे हैं. They are going further from us, stretching, going far, going further from us. And as much as they are going further, their speed of going further is increasing. और जैसे जैसे वो दूर जा रही हैं, उनकी स्पीड भी लगातार बढ़ती जा रही है. मीनिंग दे आर इन एक्सिलरेशन मोड. वो दूर जा रही हैं, दे आर ट्रेवलिंग, दे आर गोइंग फर्दर फ्रॉम अस एंड इन एक्सिलरेशन के साथ जा रही. ये उन्होंने पता किया. ये उन्होंने पता कैसे किया? बिकॉज ऑफ द रेड शिफ्ट. एक रेड शिफ्ट का उन्होंने कॉन्सेप्ट लगाया, एंड बिकॉज ऑफ रेड शिफ्ट ही मेड दोज क्लेम्स. रेड शिफ्ट के आधार पर उन्होंने कैलकुलेशंस की. एंड व्हाट इज द रेड शिफ्ट? विल अंडरस्टैंड इट. ऑफ कोर्स वी विल नॉट लीव इट. So, two observations: that universe is not just limited to our own galaxy Milky Way, it is beyond that. It may contain millions of galaxies. Billions of galaxies हो सकती हैं. And the second observations, the galaxies are not stable. Those galaxies are not stable. वो रुकी हुई नहीं है. They are traveling and going further from us and further from each other. And as much as they are going further, their speed of going further is increasing. जैसे जैसे दूर जा रही है, स्पीड बढ़ती लगातार जा रही. बिकॉज अंडर ही डिड ऑल दिस कैलकुलेशंस अंडर रेड शिफ्ट, कि उनकी स्पीड बढ़ रही है और हमसे दूर जा रही हैं. उनके मूवमेंट को उन्होंने रेड शिफ्ट के माध्यम से. रेड शिफ्ट क्या? अंडर द डॉपलर इफेक्ट. तो अंडर द डॉपलर इफेक्ट, डॉपलर इफेक्ट, डॉपलर इफेक्ट, ही कैलकुलेटेड that galaxies are not stable, they are moving away, and they are moving away in acceleration under the Doppler effect. Doppler effect was not discovered by him, by Hubble. It was discovered by Christian Doppler. It was discovered by Christian Doppler in the 19th century. But Hubble used it here. And how he used it, how the Doppler effect just works, we'll see. As we know, the spectrum of our visible light, we are understanding very important concept, Doppler effect, and how it was used by Kepler in his observations. Be very attentive to. As we know, the spectrum of our visible lights, that is Vibgyor, as we know formula: violet, indigo, blue, green, yellow, orange, and red, and red, and red. So this is the spectrum of visible light. Talking about visible light, the lights are beyond that as well. For example, infrared, here ultraviolet, various. But here talking about visible spectrum of light. So this is Vibgyor. And we know that in this visible spectrum of colors of light, as much as we go towards this side, as much as we go towards this side, the wavelength of the light increases. वेवलेंथ बढ़ती जाए, इधर जाएंगे. यानी अगर हम इधर आएंगे तो वेवलेंथ क्या होगी? घट. हियर वेवलेंथ एज मच, जैसे जैसे आएंगे उसी रेट से वो इधर आएंगे तो घटती जाएगी, इधर आएंगे तो वेवलेंथ बढ़ती जाएगी. एंड फ्रीक्वेंसी एंड वेवलेंथ दे हैव इनवर्स रिलेशन. जैसे जैसे हम वायलेट की तरफ शिफ्ट करेंगे, वेवलेंथ घटती जाएगी और फ्रीक्वेंसी बढ़ती जाएगी. फ्रीक्वेंसी जो है वो बढ़ती जाएगी. इधर क्या होगा? जैसे जैसे हम रेड की तरफ शिफ्ट करेंगे, वेवलेंथ बढ़ेगी और फ्रीक्वेंसी क्या होगी? घट. फॉर एग्जाम्पल, इफ अ ट्रेन इज ब्लोइंग हॉर्न एंड अप्रोचिंग टुवर्ड्स यू, जैसे जैसे वो आपके नजदीक आती जाएगी, क्या होगा? जैसे ही जैसे वो नजदीक आती जाएगी, फ्रीक्वेंसी बढ़ती चली जाएगी और वेवलेंथ घटती चली जाएगी. इससे क्या होगा? उसका जो साउंड है वो हाई पिच होता चला जाएगा. जैसे जैसे ट्रेन का हॉर्न हमारे नज़दीक आता जाएगा, उसका साउंड हाई पिच होता चला जाएगा। और जब वो हमसे दूर जा रहा होगा, जब वो हमसे दूर जा रहा होगा, तो क्या हो रहा होगा, उसकी वेव लेंथ बढ़ती जा रही होगी, वेव लेंथ बढ़ती जा रही होगी, फ्रीक्वेंसी घटती जा रही होगी, और जो साउंड है वो लो पिच होता चला जाएगा। So this is the concept of the Doppler effect. Here we should write it down here as well, because we are understanding a very important concept here. Doppler effect. We are understanding Doppler effect as far as our understanding in geography is concerned. तो ये तो बात हो गई जो डॉपलर इफेक्ट में बताई गई, जो क्रिश्चियन डॉपलर ने बताई, तो 19th सेंचुरी में जिन्होंने इस डॉपलर इफेक्ट को डिस्कवर किया। लेकिन अब इसको इम्प्लॉय किया ईपी हबल ने। और कैसे इम्प्लॉय किया? इसको इम्प्लॉय करके उन्होंने ये जाना कि जो उन्होंने टेलीस्कोप से गैलेक्सीज देखी, जो बियॉन्ड अवर गैलेक्सीज थी, जो हमारी मिल्की वे से बाहर थी, उनको देखा, और अब ये अपना डॉपलर इफेक्ट लगा के उन्होंने ऑब्जर्व किया कि गैलेक्सी स्टेबल नहीं है, दे आर गोइंग फर्दर फ्रॉम अस एंड दे आर इन एक्सीलरेशन। ये वो कैसे जान पाए? As we have discussed, if something is going far away from us, because as sound, as we talked about sound, the sound of the horn of the train, as much as it was just going away from us, its wavelength was increasing, its wavelength was increasing, and the sound was getting to get into the low pitch sound. Here, since light, we know light also travels in the form of wave, it also travels in the form of waves. So he said, he observed कि जो गैलेक्सीज जो मूव कर रहे हैं, हमसे दूर जा रही हैं, उनमें एक पैटर्न उन्होंने पाया कि वो धीरे धीरे रेडर होती जा रही हैं, वो रेड होती जा रही हैं, रेडर होती जा रही हैं। वो कैसी होती जा रही हैं? रेडर। वो हल्की लाल होती जा रही हैं दिखने में, बिकॉज वो लाल होती जा रही हैं, यानी वो हमसे क्या हो रही, दूर जा रही, तभी तो लाल होंगी। अगर हमारे पास आ रही होंगी तो वो रेड क्यों हो रही, तो ब्लूअर हो रही, उन्होंने होना चाहिए उनको। बट सिंस दे वर अपीयरिंग इन द टेलीस्कोप, दैट दे आर जस्ट हैविंग अ रेड स्ट्रीक ऑफ लाइट, रेड स्ट्रीक, वो रेड स्ट्रीक उनमें दिख रही थी। तो इट वॉज प्रूविंग दैट दे आर गोइंग फार्दर फ्रॉम अस, वो हमसे दूर जा रही हैं, एंड बिकॉज ऑफ द लॉन्गर वेव लेंथ। लॉन्गर वेव लेंथ जब वो दूर जाएंगी तो वेव लॉन्ग होगी, और वो कैसी अपियर होने लग जाएंगी, रेडर। तो उन्होंने देखा जो स्ट्रीक है गैलेक्सीज की, वो एकदम रेडर लग रही है, लाल सी होती जा रही है। दैट्स व्हाई ही कंक्लूडेड दैट गैलेक्सीज दोज आर बियॉन्ड अवर मिल्की वे, दे आर इवन नॉट स्टेबल, दे आर मूविंग गोइंग फर्दर फ्रॉम अस कंटिन्यूअसली, वो दूर जा रही है। स्ट्रीक ऑफ लाइट जो है वो रेडर कॉन्स्टेंटली नहीं हो रही है, वो इंक्रीज्ड वे में हो रही है, और अधिक रेड होती जा रही है, और अधिक रेड होती जा रही है, मीनिंग दैट दे आर इन एक्सिलरेशन, वो एक्सिलरेशन में है। वो जैसे जैसे दूर जा रही हैं, उनकी स्पीड भी बढ़ती जा रही है, यानी कांस्टेंट वे में वो रेडर नहीं होती जा रही हैं, उनकी जो रेड होने की जो एबिलिटी है वो और बढ़ती चली जा रही, मीनिंग दे एज फार एज दे आर मूविंग फ्रॉम अस, they are moving, their speed of kind of movement is increasing, I mean they are in acceleration. तो ये भी उन्होंने पता किया। तो ये चूंकि रेडर होती जा रही है, यानी रेड कलर की तरफ वो शिफ्ट होती जा रही हैं, इसीलिए इसको कहा जाता है रेड शिफ्ट। इन्होंने रेड शिफ्ट के माध्यम से ये पता किया कि जो गैलेक्सीज हैं वो स्टेबल नहीं हैं, हमसे दूर जा रही हैं, और कॉन्स्टेंटली दूर जा रही हैं, और उनकी जो स्पीड है दूर जाने की, दैट इज ऑल्सो इंक्रीजिंग, कॉन्स्टेंटली इंक्रीजिंग, वो बढ़ती जा रही है। So because of that, and if anything is coming closer to you, for example, any galaxy is coming closer to you, so that would be called blue shift. तुम क्या कहेंगे? ब्लू शिफ्ट कहेंगे, ब्लू शिफ्ट को हम ब्लू शिफ्ट कहेंगे, ब्लू शिफ्ट यानी वो ब्लू की तरफ बढ़ रही। उसको हम वायलेट शिफ्ट क्यों नहीं कहेंगे? क्योंकि कन्वेंशन है, इसको मान लिया गया कि if anything is coming closer to us, any celestial object, so that celestial object would be considered under blue shift. उसको वायलेट शिफ्ट नहीं कहा गया है, कन्वेंशन बना ली गई, मान सभी लोगों ने मान लिया, उसको हम ब्लू शिफ्ट कहेंगे। और जो हमसे फर्दर जा रहा होगा उसको हम रेड शिफ्ट कहेंगे, एनी सेलेस्टियल ऑब्जेक्ट द यूनिवर्स, तो उसको हम रेड शिफ्ट कहेंगे। तो ये कन्वेंशन बनाई गई। तो because the galaxies were just under red shift, that's why That's why the Hubble observed that they are going farther from us. ये उन्होंने ऑब्जर्व, दे आर नॉट स्टेबल. और कोई ऑब्जेक्ट अगर पास आ रहा होगा तो ब्लू शिफ्ट कहेंगे. जैसे कि एग्जांपल इसका भी है. Hubble observed that he said that all the galaxies are going further from us, further from each other as well. But we know now, for our precise understanding, this idea of redshift was completely true. And this idea that galaxies, all the galaxies in the universe, they are going farther from us, this was also kind of true, but with some exceptions. Yeah, exceptions, as we know them now, that our galaxy, for example, our galaxy, Milky Way is our galaxy. And there is a local group of galaxies, local group. Milky Way is the part of local group. And there are around 30 galaxies in the local group. And other closest galaxy to the Milky Way is Andromeda. Andromeda is the closest galaxy to the Milky Way. For example, this is galaxy Andromeda. And Andromeda, which is the closest galaxy to the Milky Way, is not going farther from the Milky Way, because all these 30 galaxies of the local group, they are bound by the gravity, each other's gravity. इन्होंने एक दूसरे की ग्रेविटी को बना के अपने आप को होल्ड कर रखा है. तो ये टुगेदर दे आर एक्सपेंडिंग इन द यूनिवर्स. ये टुगेदर साथ साथ जा रहे हैं, ये एक दूसरे से दूर नहीं जा रहे. ये चीज हबल नहीं बता पाए थे. उन्होंने कहा हमारी गैलेक्सी के अलावा जितनी गैलेक्सीज हैं वो सारी दूर जा रही हैं. बट इन लोकल ग्रुप, the galaxies, around 30 galaxies, they are bind together through each other's gravitational pull. तो वो जैसे हमारा सोलर सिस्टम बाउंड है, क्या अर्थ हमारी सन से लगातार दूर जा रही है? नहीं, वो तो उसी ऑर्बिट पर उसको रिवॉल्व कर रही है. ऐसे ही all 30 galaxies in the local group, they are bound by each other's gravity. वो हेल्ड हैं, आपस में रुकी हुई हैं. और एंड्रोमेडा द गैलेक्सी, जो क्लोजेस्ट गैलेक्सी है मिल्की वे के, इट इज इवन अप्रोचिंग टूवर्ड्स द अर्थ. ये अर्थ की तरफ आ रही क्लोजर, यानी इट इज ऑब्जर्विंग blue shift. That's why I tried to say it to you. ये blue shift observe कर रही है. And it is expected, it is just observed that after maybe billions of years, 4.5 billion years, this Andromeda galaxy will collide to the Milky Way. ये टकरा जाएगी मिल्की वे से. And then the hypothetical name of these two galaxies together, collision होगा, इसका मतलब ये नहीं कि कोई वहां पर blast हो जाएगा. Meaning they'll come together, because there is tremendous space in between these galaxies, objects in these galaxies. So that space will be filled and they'll be together. And then they together will be known as Milkomeda. Milkomeda, including Milky Way and Andromeda. So this Andromeda is under the blue shift, just to broaden your understanding of the concept of redshift and blue shift. Although this was not suggested by E.P. Hubble, E.P. Hubble talked about only redshift. That all the galaxies beyond our galaxy, they are going farther from us because of the redshift observed, because of the redshift being observed. So this was suggested by this E.P. Hubble using his powerful telescope under the Doppler effect. And due to this contribution of the E.P. Hubble, as we know now, in 1990, NASA in the United States, Space Agency of United States, it launched Hubble Space Telescope, HST, in the honor of E.P. Hubble, discoveries of E.P. Hubble. तो हबल स्पेस टेलीस्कोप ये 1990s में नासा द्वारा लॉन्च किया गया था. इट इज स्टिल ऑपरेशनल. जस्ट टू ऐड अप करंट इंफॉर्मेशन. ये हबल स्पेस टेलीस्कोप जो लॉन्च किया गया था डिकेड्स एगो, ये स्टिल ऑपरेशनल. ये इन्हीं के ऑनर में लॉन्च किया हबल स्पेस. इट इज स्पेस बेस्ड ऑब्जर्वेटरी में बहुत सारे कैमरे लगे होते हैं, हाई पावर टेलीस्कोप्स लगे होते हैं, जो कॉन्स्टेंटली अर्थ के अराउंड रिवॉल्व करते हुए बहुत सारी चीजों को ऑब्जर्व कर रहे होते हैं. So this was in the honor of E.P. Hubble. Now we see that how the heliocentric model was just extended by the contribution of various scientists and thinkers. इन्होंने हेलियोसेंट्रिक मॉडल को नेक्स्ट लेवल पे ले जाके E.P. हबल ने तो उसके भी बियॉन्ड जाके यूनिवर्स को एक्सप्लेन करने की कोशिश की, ट्राई किया. उसके बहुत सारे उन्होंने प्रूफ्स भी दिए, because he used scientific evidences, red shift, blue shift. these are not just talk of the town, these are evidences. उन्होंने रेड शिफ्ट का एविडेंस उन्होंने ऑब्जर्व किया इसको. So those things were completely based over the scientific observation as done by E.P. Hubbard. तो लोगों ने उसको मानना चालू कर दिया. Now our pursuits of just going diving deeper in the universe that is started. अब हमें समझ आने लगा कि यूनिवर्स जो है वो बहुत बड़ा है. It includes various clusters of galaxies and we just our understanding of the universe it broadened. अब हम जो है हमारी अंडरस्टैंडिंग बहुत ही ब्रॉड होने लगी. So from the contribution of these scientists and astronomers, we got to know, we discovered the universe. That's how we discovered the universe. So this is all about today's discussion, and we thoroughly tried to look into the discovery of the universe, the heliocentric model, and in our next lecture, we'll be meeting with the new topic. Thank you very much for joining in. Have a good time.